Hi guys, in this video I just wanted to offer some further clarification on the chain rule and how to use it. So when you were originally taught the chain rule, you might have been taught it something like this. If you've got ax plus b to the power of n is y, then the derivative of that is going to be a times n times ax plus b to the power of n minus 1, which is correct, but that is only one application of the chain rule in a very specific instance. The general chain rule, as you will need to understand it, is of this form over here. So essentially we apply the chain rule when we have an outer function and an inner function. In this case, g of x and f of x is the inner function. And what it allows us to do is we can differentiate this whole expression with respect to x with this simple equation here. If we have y equals g of f of x, dy on dx equals dg on df times df on dx. And that might sound somewhat confusing, but as we get into the examples, I think it will make a lot of sense. So we can apply this formula here to all of the functions that you're required to learn for the syllabus. The first one, which should seem most familiar, is if we have the outer function, the g of x, is just a simple power, so let's say the power of n, and the inner function, let's say, is f of x. This dg on df, as you all should know, is f to the power of n minus 1 all times n. And so a simple way of doing that would be like, imagine instead of f of x in here, you just had some variable u or t, and if we wanted to differentiate dy with respect to dt, and it was y equals t to the power of n, I think you would all agree that that's going to be n times t to the power of n minus 1. And that's how we gain this part of the expression here. And then simply multiplying that by df on dx, which we express as f dash x, which is going to be the derivative of the inner function, whatever that may be. So that's how it sort of splits up. This one is dg on df, and this one's df on dx. And then we sort of go through and we apply that to all the other functions that you learn. So e to the f of x, we know that the derivative of e to any power, the derivative with respect to f when it's e to the power of f is just going to be e to the power of f again. And then all we need to do is, again, if we go back to our formula, multiply it by df on dx, which can be written shorthand as f dash x. And that's how we obtain all these formulae here, which you will find on your formula sheet. And so now I'll just get straight into some examples. So first off, we have y equals e to the 2x. The outer function here is e to a certain power, so e to the power of x, and the inner function is 2x. So dy on dx is equal to dg on df times df on dx, which is going to be the derivative of the outer function, e to the power of f, is just going to be the same, so e to the power of f, which is e to the power of 2x, times the derivative of this inner function. The derivative of 2x is simply 2, so that's going to give us 2e to the 2x. Quite simple. The next example, this one's a little harder because it's sort of not as clear with this notation, but what this actually is sine x all squared. So for this function, the outer function, if you will, the g is squared, and the inner function is sine x. So we've got dy on dx is equal to dg on df times df on dx. And you might see other letters used other than g and f. I see u a lot, but the important is to understand the distinction between the outer function and the inner function. So derivative of the outer function, this 2 comes out the front, still keep the sine x, and that'll just be to the power of 1. And then the derivative of sine x is cos x, and that's this df on dx here. And so that's 2 sine x cos x. Okay, and now cos x squared. In this one, the outer function is cos, the inner function is x squared. So dy on dx is going to be negative sine of x squared times the derivative of that inner function, which is 2x. So we'd probably write that as minus 2x sine x squared. I'll put that in brackets as well. There we go. And now moving on to the last one, log of x. So the inner function and the outer function are the same in this one. Through the outer function, log of any f of x will be 1 on f of x. So we end up with 1 on log x times, and the derivative of this inner function is going to be 1 on x. So it just ends up simply being 1 on x log x. Okay guys, I hope this clarification helped with your understanding of the chain rule, and I'll be making a video soon with some more difficult examples.